Alright, we did the December contest bronze, why don't we do silver now? It's gonna be epic. So I guess Stuck in a Rut is also on silver, so why don't we just start with that, because we already solved that in the bronze video, so let us hope. Okay, well, n is only 1,000, so n squared works, and my algorithm from the previous video was n squared, so I think we should be good. Oh, but it's different. No, it's different, god dang it. This is so sad. Okay, Farmer John has recently expanded the size of his farm, so from the perspective, okay. What's the difference though? Okay, what is the output? Oh, blame? What? Okay. So, he doesn't like the guy. Alright. Oh, so you gotta count how many people each cow stopped. So, essentially we could just use the same strategy we used for the bronze problem, except now we just have to, keep track of who, or how many people they stopped. Which is pretty easy to augment on our previous solution, so let me just explain it again, and then we could code it up again slightly differently. Alright. So basically the idea is we have our coordinate plane, we got like some dude going east, we have some dudes going north. I'm not going to use the test case because it's actually a bit confusing, but we have a bunch of guys going east and a bunch of guys going north. Okay, so essentially the idea is, and I guess there's some north guys going here, or like on the left side, right? And basically the idea is we go from bottom to top for the east guys, like we start with this guy, and then considering this guy, we go from left to right on the north guys, right? So you first look at this guy. This guy is for sure not going to collide with this guy because he's to the left and our east guy is moving east, so there's no way they're going to collide, so that's fine. Then we go on to the next guy, which is this guy, and we know that, and basically we check, will this guy be stopped by this guy? And the answer, let's just say, is no, so it keeps going, and if this guy keeps going, then this guy must be stopped by this guy, right? And then eventually this guy gets stopped by this guy, and we could keep track of that. And then we move on to the next one and repeat the process and keep track of which ones we stopped over here. Anytime a cow stops another cow, then we just add to its total. Okay, let's do it. So I am tempted to do this in Python, why not? If you guys want a slightly more clear explanation, you guys could watch the bronze video, but I think you'll understand it once I code it up. Okay, so we'll call it rut, let's do it. Alright, so let's read in the stuff. And we just do that, okay. And then for I in range n, so our line is going to be equal to input, so that's going to give us one line of input, and then we split it, so we should probably split it first here. And basically we want to keep two separate lists, right? We want to keep track of the people who are east facing, so the ECs, which are the east cows, and then we want the north facing cows, which are NC. So if line 0 is equal to E, then we want to add it to EC.append, and we want to the way we did it in the other one is we had a tuple of the index, right, so I, and the x and y coordinates, which are going to be line 1 and line 2. And we should probably convert these boys to ints. Okay, so once we have that, we should also do the same thing for the other case, and we change it to NC. Alright, so now that we have this, we want to sort it by the thingamajig. So we do, what do we do? ec.sort. And then we do by key is equal to, so then we want to sort by the second element of the tuple, which is x coordinate, right? So we want to, we want to sort the east guys by y coordinate. So we do lambda of x and we return x2, which is the y coordinate. And then we do the same thing for north, except we sort by x1, which is the x coordinate. And we say north facing. Okay. So now, as I explained, we want to keep track of which north-facing cows are stopped, right? Because if they got stopped by a previous east-facing cow, then we don't want to consider them for the guys above, right? Because it can't stop the guys above if it's already stopped. Okay, so we'll have a stopped array. That's not how you spell stop is equal to, and then we'll set it to like false for all the n, so times n. And we also need to keep track of each dude's blameworthiness, right? So we'll basically have blame is equal to 0 times n. Okay. So now we basically loop through, do we want to loop through, okay, so I want to loop through all the east-facing dudes, and then for each east-facing dude, we want to loop through all the west-facing dudes. So we just do range len ec, and for j in range len nc. Okay, so now we want to ignore all the guys who are left of our ECI, right? But we want to, and all the guys who are above our ECI, right? Like if we go here, like, this north-facing dude cannot collide with this east-facing dude because he's above. This guy can't collide with this east-facing dude because he's to the left. So neither of those cases can collide. So if NCJ2 is the y-coordinate is greater than ECI2, or the x-coordinate of the north-facing guy is too small, NCJ1 is less than ECI2, 1, okay. And then there was another thing, or stopped. If it's stopped, then we also don't want to consider it. Or stop j. Then we continue. Otherwise, if that is not the case, then we basically want to see who will collide with who. Will the north guy stop him, or will the east guy stop the north guy? And basically, the equation for this is, let's see. So essentially, I think 3, 5, and 8, 1 is the example I used for the other one. Wait, what? What? Was there 8? Oh, they changed the example. So 9, 2, I suppose we will do. 9, 2. Wait, that's not even north facing though. What about 11, 1? Oh yeah, so basically, the amount of time it takes this guy to get over here is 11 minus 3, which is 8. And the time it takes this guy to get over here is only 4. So clearly, this guy will get there first, and thus this guy will be stopped by this guy, right? So essentially, if 11 minus 3 is greater than 5 minus 1, then this guy will be stopped by this guy. So, if NC, so it's the north-facing guy of 1, right? X-coordinate minus the east-facing guy's x-coordinate is greater than the east guy's y-coordinate minus the NCJ y-coordinate. In this case, then the east guy is going to stop, in which case we say that the north guy stopped the east guy. So we'll do blame of north j, and then its original index, which is stored in the 0th spot of the tuple, and we do plus plus, or plus equals 1, because Python sucks. God dang it. No, I'm kidding. Python's pretty clean for this one. And then we break, right? Because our east guy got stopped, right? So there's no reason to keep running the loop. This loop is for collisions of this east guy. So if he stops, he can't collide with any of the following north guys. Now the other case is lastly if this thing is flipped, right? If they're equal, then they don't stop each other. So we had to do is less than. Okay, elif right here, and we basically say blame of the east guy increases by 1 because he stops the north guy. So blame ECI 0 plus equals 1. And we gotta say, keep track that the north guy has stopped. So stop of the north guy, which is j, is equal to true. Alright, nice. And then at the very end, we just go through and we print the blame. So for I in range n, print blame I. Okay. I mean, technically we could just go for I and blame print I, but this works too. Let us do it. 0, 0, 1, 1, 1, 0. Why 1, 1, 1, 0? So this dude, the 2 is the east 10, 4. So the east 10, 4, he stops both of these guys? Who else did he stop? Oh, wait, what? By transitivity? Wait, hold up. What? Wait, that's so troll. Okay. So essentially, if you stop somebody who stopped somebody else, you stop all the guys who that person stopped. So in that case, we gotta do plus equals blame of the guy you're stopping. So plus equals blame of the ECJ0, or ECI0. Okay, and same thing here, except it's opposite, blame NCJ0. Okay. Oh, wait, hold up. So, plus 1, because you're stopping that dude as well. Alright. Hey, there we go. Okay, I think this should work. Let's do it. Hey, nice, we did it, boys. Very cool stuff. Now we go on to problem number, let's start with 1. Alright. Cowntagion. Now I actually had to read the question. Farmer John and his fellow farmers have been working non-stop to control the spread of the terrible bovine disease COVID-19 across their farms. Together they oversee a collection of N farms, okay, conveniently numbered 1 through N. The farms are connected by N-1 road, so it's a tree, right? Like, there's only one way to get to another farm there's only one way to get from one farm to another. And unfortunately, a cow in farm 1 has just tested positive. Okay, so none of the other cows have the disease yet, and basically he predicts that each successive day in a single farm, a super spreader event causes the number of... Okay, so at that one farm, at farm 1, it might double at that thing, okay? Or a single cow with COVID-19 moves along the road, okay? So, he wants to determine the minimum number of possible days before at least one cow in every farm had the disease. So basically, this event doesn't really matter, right? Because it only matters if a cow moves, right? If the amount doubles, it doesn't really matter because we only care about like if there's at least one. So we don't have to worry about that event. Only this event is bad. Okay, so we get in the roads, basically, that's it. And then we want to say the minimum number of days until the outbreak could reach every farm. What? Wait, is this not... What? So I guess we just assume that the event is always just like Wait, yeah, don't we just assume that the event is always a cow moving to another farm? Oh, I see why it's relevant. Oh, I see. Because basically, wait, what? A single cow has, okay, yeah, the problem is because if it's at one, once a cow moves, he can't infect other people at that farm. Oh, I see, okay. Yeah, because if the guy moves from one farm to another, then the original farm no longer has a spreader. Okay. So I guess basically the optimal solution is you basically double yourself, right? And then you move, right? So in any case, you should always double yourself before you move. Oh, but I guess if you want to send out like 4 dudes, then it makes sense to double yourself twice before moving though. Okay, maybe this is not that smart. Okay, let's think. So n could be 10 to the 5, so we had to be a bit smart about this, but let us just look at how this looks. So farm 1 is connected to 2, 3, and 4, and essentially there's one super spreader right here, or there's one cow here, and basically we want to duplicate that to 2, and then we might want to, or then one guy moves, we duplicate the other guy, and then both, no. So ideally in this case, I guess you go 1, 2, 4, so that's 2 days, and then on the next day, all 3 of those cows move, or 3 of the 4 cows move, and then you get all 4. So, wait, what? Oh, but only a single cow moves at a time. So, yeah, so essentially it takes 2 days to get to 4 cows, and 3 days for the rest of the cows to move. Huh, what's a smart way to do this then? Huh, so does it ever make sense to do the growth steps separately? Like, does it ever make sense to move and then duplicate instead of duplicating as many times as you can and then moving? Is that ever better? Because I feel like the guy in one should just duplicate so there's like n many cows there, and then each cow should just go as fast as it can. Oh, but the problem is like, oh, I see. Yeah, the problem is like you can only move one cow each day, so ideally you create the cow as close to its destination as possible. Okay. This is kind of complicated. Okay. Okay, I think that makes sense. So basically, there's no reason why a cow would go to 3, duplicate itself, then send another guy back to 4, right? Like, anybody who's going to 4, you should duplicate here and then send that guy to 4, because that would be the shortest distance. There's no reason why you would want to send a cow from 3 back up to 4. So essentially, I think the idea is you duplicate until you have enough cows to get to each of your children, right? So in this case, there's 4 cows, and then you can send 3 down. But what happens if there was someone here, right? Then basically you send a cow there, and then he duplicates twice, so now you have 4, and then you can send 3 children down here, and then you're good. Okay, I think that's the optimal solution. So basically this is just like kind of BFS, right? Or DFS? Yeah, BFS kind of. So basically you count how many children you have, right? And then you duplicate to that many cows, and then you send and then you then you send out those cows, and then you repeat the process for each of the kid nodes. All right, let's code it up. All right, so we'll do Python again because we're cool. I think we might do C++ for the last one just for fun, but we'll call this, what are we gonna call this? Cowntagion. Okay. So n is equal to int of input, and then for I in range n minus 1. We want to keep an adjacency list. I'm assuming that's the best way to do it. So the way you make an adjacency list is you do adj, and then you do this for I in range n. All right. So we want to read in each line, so we say line is equal to input dot split, and we want to map into both of those. And essentially what we do is we basically do adj line 0 minus 1 dot append line 1 minus 1, and we do the same thing because it's bidirectional. Very cool. I like zero indexing stuff. Like, honestly, it doesn't really matter, but zero indexing is a lot easier. Okay. In my opinion. So now basically what we want to do is we want to define a function, right? We're going to do this using recursion because like the logic is the same for each node, right? So essentially if we use recursion, we could reuse a lot of our code. I mean, technically you could use BFS too, but DFS is easier in my opinion. So why don't we do that? Def process, why not? We'll take in the car node and our parent node, and we'll take in the adjacency list. Okay, so essentially we want to go through all of the children. So for I in, and we should keep track of how many children there are, so children equals 0. And for I in range, or I in adj, we basically check if I is equal to parents, then we just want to break. Or no, we want to continue because we don't want to go backwards, right? We want to keep going down to the children, so continue. Okay. Otherwise, we add to our children, so children plus equals 1. And we want to also process the kid. So process I, and the parent is the current node, right? And we want to pass an adj again. And what else? Okay, yeah. So essentially, we need to have our overall cost, right? So we'll have process return the cost, right? So essentially, we'll have cost is equal to 0, and essentially, every time it returns, we add to the cost whatever process returns. And then for the current node, we want to use our logic again, right? So it has to duplicate until it reaches the right number, right? So let's see, what is the number? Essentially, you take the log, right? So basically, if there are 3 children, then you want to do 3 plus 1 is 4, and then you take the log of that and you floor it, right? So, no, you're stealing it. Wait, what? You're stealing it? Yeah, you're stealing it. So if there was 4 children and you wanted 5, that means you would need 5 cows, right? Then you would essentially need to duplicate 3 times to get 8 so that you can send 5 guys out, or 4 guys out. Oh, so that's kind of smart. So basically, like, I think the easiest way to do this is we can find the bit length of it, right? So for 3, the bit length is 1, 1, right? Because that's the binary representation. So we would need 2 divisions. For 4, we would need 3 divisions because you have 1, 0, 0, right? So I think in Python you could do dot bit length. Let me check. Okay, I'm assuming hopefully you could actually do it, right? So essentially we just do cost plus equals children, because you had to send a cow to each children and it takes 1 day to send a cow to each child. And then we also had to add plus children dot bit length. Okay. And then we return cost. Very nice. And then at the very end we just print process 1. Or process 0, -1, and our ads list. I don't know why I did that. Okay, there we go. That's what we want to do. Oops, what happened? Dot append. Map object is not subscriptable. Oops, we should probably listify this. List. Okay. Maximum recursion depth. Okay, I think, if I equal parent, so that means they shouldn't be able to go back up, right? So it will go, huh? Oh wait, why did it? Oh, I in adj what? Adj car. Okay, that would make more sense. Cool. Also, this should be a function, right? Okay, right way to do it. Hey, it works. Okay, nice. Let's do it. Bro, that's actually so clean. I did not expect it to look that clean at the end. Okay. Well, we'll see if it works. We'll see if it works. Hopefully it works. Reading in progress. Hooray, I think we did it. Or will it time out? Python time limit is massive, so should be good. We should be good. Hey, very epic. After like 10 seconds, we finally got our result, and it is correct. Nice. Okay, rectangular pasture. Fun. Okay, so basically, Farmer John's largest pasture can be regarded as a large 2D grid of square cells. Okay. Currently, there are n cows occupying some of these cells. Alright. 2,500, how bad is that? I think we could do n squared on that, so it shouldn't be too bad. Farmer John wants to build a fence that will enclose a small rectangular region of cells, okay, and it must be parallel, alright. And it could be as small as a single cell. Help him count the number of distinct subsets of cow that he can enclose in such a region. Note that an empty subset should count as one of these. Alright. Well, I mean, in any case, you for sure could, you could for sure get an empty subset. So that's like you just start at 1 and then count from there. And then the first line contains an integer n, and then you basically have all the cow coordinates. Okay. Hey, if we do it in Python, we don't have to worry about that stuff. I mean, long should be fine in C++. You know, why don't we just do everything in Python? So I can put in the title, Python walkthrough. Very nice. Okay, so let us draw this out. So we got 0, 2, and we got a 1, 0, and we got a 2, 3, and we got a 3, 5. I mean, what? Can you just like do any subset? Or what subset can you not do? So you could do these two, you could do these two, you could do these two, you could do these 3. You can't, wait, you could do these 3. What's the, what subset can you not do? Oh yeah, you can't do these. So, let us think. Okay, why don't we think about it this way, right? So essentially, n squared, right? So you have 4. So let's just say we start everything at like, how do we do this? So obviously what we could do is we could just go through every single pair of points and set those to the opposite corners, right? And then just check if there's like, and then just check if that's a unique subset. Wait, won't every single corner thing, if you set every 2 to a corner, won't that be a distinct subset? So okay, let's say we set this 2 to a corner, that's one subset. Why don't we go through it methodically? So this corner and this corner is a subset, right? Okay. This corner and this corner is a subset. Wait, how do you even get it so that it's not unique? Is it possible to get it so that they're not unique? Or like, huh? Oh, I guess you don't. Oh yeah, cause like for this one it's different. Cause this doesn't have something at its corners necessarily. Okay, so that's not gonna work. What else? I mean, obviously some kind of line sweep thing might work, right? So essentially, uh, we set an enclosure where it's basically just like these two lines, right? And then we could expand it, right? So if we expand this guy, right, then this guy will be in it. Then if we expand that, then this guy will be in it. But then we missed this guy only. Actually, wait, we have n squared. So what happens if we expand that guy, right? Oh, but I see. Like, okay, so the idea is that not all of these are unique subsets, right? So, okay. So why don't we just like fix the left and right bounds, right? So let's say these are a left and right bounds. Then essentially, for every bottom and top thing, it's unique, right? So, um, is it unique no matter what we do for a bottom and top thing? So yeah, like this is unique. That's unique. That's unique. Okay. Then what happens if we put it there, right? Then doing this and doing this are the exact same, but like this and this is different from this and this is different from this and this. Okay. Okay, so let's think about it. So essentially, let's just vary the two lines here. So let's say it starts here. We only have one thing to choose our vertical line. So it's like 1, choose 2, which we'll just say is 1 because there's one way to do this, right? Like that. Then we could sweep over another one. So now these two guys are in the same thing. So now there are two guys to choose from, and we could choose top and bottom. Or we could choose, Oh, so they don't have to be distinct necessarily, right? So we could have like, so they could be on the same dude, or they could be different dudes. Okay, so if they're on the same dude, then there's basically two ways, right? And if they're on different dudes, it's just plus 2 choose 2. Yeah, so, okay, that makes sense. So this would be 3 ways to do that, okay? So we had 1 from our first time, and then we have 3 for this guy, and let's expand it another time. So we have like that, and like that. So now it is these 3 guys. So essentially we have 3 plus 3 choose 2, which is going to be 3, right? So plus 6. Wait, that seems wrong, right? Oh, because we already counted the single dudes. So we overcount, I guess, right? Because, so how do we not overcount? Kind of confusing, gutting. Okay, so we don't want to overcount this dude and this dude because we already counted that. So I guess if we guarantee it has to include this guy as a boundary. Well, that's not true though. Hold up, this is actually kind of complicated. Okay, so how do we count subsets? Let's see. So there's like 2 to the n subsets that we probably should not. We can't like count each one individually. Maybe there's a smarter way to do this. Okay, let's try again. So we have 2 0 1 0 2 3. Okay, so I think basically the idea is so right here our topmost and bottommost point are right here. So essentially there's one way to do that. Okay, now when we expand it, our new guy is below both those bounds, right? So essentially the only way to make it new is to either move both the bounds here or to have one up there and one down there. So we had to move at least one of the bounds to make a new thing. So essentially we add 2, right? Because we could either do this is new and that is new. Okay. Then if we move it over again, right? Now this guy is above like the previous upper and lower bound, right? So essentially he doesn't fit into any of the previous ones. So the only valid ones are extending it up till here or like here, right? You have to include this guy somehow, right? So you need one bound here, and then there are 3 ways to put the second bound. So here, 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 so plus 3, okay? And then the last guy, if we extend it again, he's above everything, right? So essentially you have to include him at the top bound and then anything below. So that is plus 4, okay. So then now we could start again, except now we have starting here, starting on this dude. And essentially the 2 bounds are here, right? Then we add in this guy, so that's plus, well, we already counted that, so how do we not overcount that? Well, I guess this is guaranteed different because all the previous ones had to include, no, but they didn't have to include that guy though. So, maybe we could do it based on which, like, how many subsets are there where this guy is included, but then that would have a lot of overlap, right? Yeah, so we already counted this. How do we remember that we counted that though? Okay, let's think. Okay, let's start again. Okay, hold up. Alright, so you have to put 2 here, right? And like that. Okay, so now when we expand, we basically want it so that like everything in the horizontal range is, or rather there should be something on each of the bounds. So you can't have both other guys here, right? Because then this bound would not have anything on it, right? So essentially, the only valid one would be these two, right? Okay, so that's 1 plus 1, okay, and then we go over here, and essentially, the only bounds that are valid, right, we have, well, okay, so this guy needs to be in there because he's the only guy on the rightmost bound, so we need him there, so he's also the tallest, so that goes there. Then we also need this guy, right, because if he was not there, then we wouldn't have the left bound, so he has to be included, so we put him in. But this also works if we put it down here because the original guy is included. So basically anybody below the original guy would be fine. Okay, so that's 2. 2 are valid, plus 2. And then we finally go to this guy, and basically the idea is he's on the right, so he has to be included in this set, right? So and he's the tallest guy, so that's fine. And basically the last guy has to be this guy or somebody below him, so another plus 2. Okay. And now we go back to, we move the first line. Alright, so essentially if we go here, right, so now this is that, and that, so that's plus 1, okay, then we go like that, and then we know that has to be like that, alright. Okay, so we basically know that the top line has to be at or above the guy on the right side, okay, and we know that the left one, the bottom one has to be below, or, yeah, it has to be below, well, yeah, you can't, yeah, it has to be below this guy. So in this case, there's only 1, again, because, yeah, alright. And then we put it over here. In this case, has to be above or at this guy, below or at this guy, so another plus 1. And then we're on to this, right? So we're here, and the first one is plus 1, right? And then we have these two guys, and that's just another plus 1. So that is 6, 10, 13. Hey, okay, so that's how we do it. Dang, that's fancy. Okay, so basically you have a left guy and a right guy, right? So let's say the left guy is below the right guy. Well, let me draw it out. So there's basically 2 cases, right? Essentially, we're looping through. We're essentially looping through. We're looping through the vertical lines, right? So that's n squared time. And basically, there's 2 options, right? The left guy is below the right guy, right? In this case, the upper line of the set has to be at this guy or some guy above him, right? That's in between these lines, right? Or it has to be at this guy or below him. So you basically have to keep track of how many guys are below and above this guy and how many dudes are above and below the last. Alright, seems legit. That would probably take log n time, right? Let me think. Okay, so how do we do this slightly smartly? Well, yeah, you just multiply like how many lines there are here times how many lines there are there, but how do you keep track of that? Okay, yeah, so this seems like 2D prefix sums, right? So basically, like, we keep track at this y coordinate, how many guys there are above it at each interesting x coordinate, right? So, like, basically, you could draw lines for each one, and you keep track of, like, the overall sum from 0 to here, and then, okay, let me draw this out for the sample test case. So basically, I drew lines for all the interesting x coordinates, right? And basically, we want to keep track of how many are above this line for all the x coordinates. So right here, 0, 0, 0, 1, right? For this y coordinate, right? Then for this guy, it is once again 0, 0, 1, 1, right? Because it's the cumulative, right? That's what prefix sums do. And then for this guy, it's just going to be like what? 1, 1, 2, 3, right? Because basically this guy's above him, this guy's above him. All right. And then for the last guy, it's going to be 0, 1, 1, 1. Or no, sorry. 1, 2, 3, 4. Okay, so now if, like, for example, we got to this guy and we wanted to see how many options of lines there are between, like, this x coordinate and this x coordinate, how many guys there are above here, right? Then we just take this minus this and we get our answer. I think a cooler example would be like this, that, right? So essentially this one's going to be 1, 2, 3, 4, right? And if we, for example, well, okay, maybe we should do a better example like this. Then it's 0, 1, 2, 3. So let's say that we had our left line here and our right line there, right? then essentially if we wanted to see like how many and we wanted to see how many options there are for this line, there are 3, right? So literally all we would do is we would take 3 minus 0 and we would get our answer is 3, right? So we would get 3 lines like we wanted. Let us say that we added in another like dude over here, right? Then it would still be 0, or sorry, if we put another guy there, it would still be 0, 1, 1, 2, 3, right? So essentially, if we made our left and right line like this, then if we wanted to see how many possible lines there are here, then there are 3 minus 1 is equal to 2, right? There's this line and there's that line. And then we just multiply. Clearly, there's only one possible line here, so in this case, we would add 2 times 1, which is our answer. Okay, so essentially, we need two 2D prefix sums, right? We need our, like, above a certain y coordinate, and we need below a certain y coordinate. So why don't we code this up? I think we get the idea. Let's do Python again. Rect past. Why not? Okay, so n is equal to int of input, okay, and then we go for I in range n. We could just do like, well, how do we want to store this? So we want to have it sorted by x, and we want to have it sorted by y. So we'll have like x sort, and we'll set that to a list, and we'll set y sort to a list as well. And we will basically have xy is equal to tuple of input dot split, and we want to map into it. And we just do xsort dot append xy and ysort dot append xy. And we sort it. Okay, so we just do xsort dot sort, and we do key is equal to lambda x of x0, and same thing for the other, except by the y coordinate. Okay. Actually, I don't think that was the right way to do it. Let's think. Oh, we don't even need ysort, dude. We only need xsort. Okay, let's just take that out. And essentially the way we're going to calculate this stuff is basically we're just going to go through each, right? So for this guy, we go from left. Is there anybody above this guy? Yes, there's one guy because he's above himself, right? Then we go here. Is this guy above him? No, so we don't add anything. Is this guy above him? Then, so this would be 1. Is this guy above him? Yes, so that would become 2. Is this guy above him? Yes, so that would become 3. And we basically just do that for each. So for int how do we want to do this? Also, we should probably keep track of the index of each. Is that relevant? Original index. Oh, yeah, it's not relevant. We only have it stored in one place, so that is fine. So for int, wait, what am I doing? That's not Python. I in range, n. And then for j in range n. Okay. So now we have to keep track of our 2D sums, so it'll be like, what, above sums, I'll just call it above is equal to, and then we want an array of, what, zeros times n, and then for I in range n, and we also want a below. Okay, so essentially, I is the thing we're comparing to, right? So essentially, if, if xsort j, and the y coordinate, which is 1, is greater than the xsort I, or greater than or equal to, then we will do above j plus equals 1. Also, if the xsort j1 is less than or equal to xsort I1, sorry, above ij, okay, xsort I1, then we do below ij plus equals 1. Okay, so now we have our prefix sums, and basically we just do the algorithm I was talking about, right? So we'll have our total is equal to 0, and we'll go through the entire thing. So for I in range n, stopping parentheses, god dang it, I in range n. And then, what do we want to do for j? So for j is for sure going to be right of I, because we're looping through the left and right. So for j in range I comma n, I plus 1, no, I plus n. Okay, so what was the formula again? So essentially, we would find which one is higher, right? So if this guy's above this guy, then we want people above this guy and people below this guy. If it's the other way around, like this, then it would be people above this guy and below this dude. Okay. So if if xsort j1 is greater than or equal to, well, I guess they're not ever equal to, but yeah, whatever, it doesn't matter. It doesn't matter? I think it does actually. Okay, it doesn't matter. Okay, so xsort greater than xsort I1, then we want to do it so the right side is above the left side. Okay, so essentially we do above of So we basically do above ji, right? Or above jj, right? Above jj minus above ji. We do tot plus equals that times below I or below ij minus below I times below ij minus below I. Okay. And then conversely, we just flip it around. So instead of doing above ji, we do below. And instead of doing below, we do above. Unless it's on the same dude. If it's on the same dude, then we gotta... Well, what do we gotta do if it's the same dude? It should be non-zero. Oh, no. Oh, wait, hold up. Now, hold up. So do we want to do minus before? Oh, it's inclusive. So yeah, we want to do j minus 1. Or I minus I minus 1. So why don't we do 0? Oh, huh. I guess we need to shift everything up. Oh, we gotta shift everything up, dude. Okay. Actually, wait, that's kind of big brain. We could just do times n plus 1, right? And then the negative 1, if it tries to act as negative 1, it'll wrap around and get a 0. And we do minus 1 here, minus 1 there, and minus 1 there. And at the very end, we just print top. Alright, let's test it. For sure not going to work first time, but we could test it. Yep, it didn't work. Let's see. Let us first print out our print xor. Or no, above 1, 0. Wait, hold up now. Hold up. How did he go down? Oh, we're supposed to use prefix sum, dude. Above is... Or okay, so essentially, before any of this, we had to set above is equal to above I, j minus 1. J is not equal to 0. Actually, wait, that's fine, because we have the wraparound, dude. I love Python. Python has, if you do array negative 1, it goes to the end. That's so good. God dang it. Alright. And we got below. Good thing we did Python, dude. I would be so triggered if we were doing this in C++. Okay. 1, 1, 2, 3. Okay, 1, 2, 3, 4. And 1, 2, and 0, 0, 1, 0. Okay, nice. Right? Is that right? So essentially we have this, we have that. So the first guy in XOR is going to have 0, 0, or sorry, 1, 1, 2, 3. Then this guy is going to have 1, 2, 3, 4. Then this guy is going to have 0, 0, 1, 2. Okay, makes sense. And our tot is 12 though. Oh, okay, so we just do tot plus 1 because we for sure have an empty set that works. So that should be good, and we get rid of this, and we submit. Nice, let's do it. Please work, please, I beg. Hopefully, please do it. Hey, let's go. Very nice. Bro, why is Python so slow? Okay, I gotta say, Python's really nice though. Come on, you gotta admit, that was beautiful. Wait, what? Timed out? Dude, how? What? It's like n squared. Is n squared too big? Bruh, no. Okay. No, this is so sad. Maybe if I did it in C++, it would have worked, but apparently not. Wait, what? How did that even work? So the n squared too slow. What is... Okay, so 13 to 20... Oh, so anything above 500 doesn't work? What? Am I doing something wrong? No, hold up. N squared, right? This is for sure n squared. I don't see any way it's not n squared. Bruh, did anybody see where I'm going wrong? Hold up, what? Okay, you know what? Let's do the time-tested way of figuring out what the problem is by printing out 13 and then commenting stuff out. So let's see what happens if we comment out the last part. Alright, let's try that. Okay, so that still times out. What about this? Maybe I would have been better off doing this in C++. God dang it, dude. I'm pretty sure. I bet, like, this is what the problem is. I bet, like, just initializing the arrays is what's taking so long. Really? Okay, never mind. Nah. Okay, so it doesn't like this loop. Okay, so I guess if we speed up that loop, it should be fine. Let's see what happens if I just do this. Okay, so n squared just in general is too slow for it. What? Seriously? Wait, no way, right? N squared is... What? Okay, you know what? I'm pretty sure n squared should work, so I'm just gonna put it in C++. What? Seriously? It doesn't work in Python? What? There's no way, right? Okay, I'm just gonna do it in C++. I'm not gonna explain it because you guys already know the logic, but hopefully this works. Alright, so we converted it to C++. Let's see if this works. It better work, otherwise I'm gonna be so triggered. God dang it. Like, dude, come on. 2500 is for sure okay with n squared. I don't get it. Okay, moment of... What? Wait, what? Hold up. What? That uses the exact same algorithm. Come on. Wait. Okay, but it doesn't time out. Oh, here. Okay, this should be from I. Okay. Bro, that's so stupid. Why did the Python time out, dude? And I literally even ran like a longer for loop on C++ and it didn't time out. Okay, maybe I know I've told you guys that if you have the right algorithm, like Python should not matter. That's crazy, dude. That's literally the exact same algorithm, and this one doesn't even come close to timing out. I don't get it. Yeah, I don't know. All right, I guess like wait, where? I just what? Hold up. Oh, okay, yeah. So I just need long for the total, and we should be good. Bro, I'm actually so triggered though, dude. I really thought Python was fine regardless, but I literally have the exact same like algorithm and it still doesn't work. Maybe there's something I'm missing. Maybe there's like some like weird runtime thing in Python that like I was doing it inefficiently, but I'm pretty sure like that was literally the same algorithm. Okay, I don't know. Okay, if I was doing anything wrong in the Python code, let me know. But like I really just converted it exactly how it was to C++ and it worked. I don't know. But anyways, yeah, there we go. We finished 2020 December Silver. Hope you guys enjoyed. Thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Let me know what else you guys want to see. I'll probably work on some of the gold problems a bit later, but we shall see. I don't know. But anyways, thank you guys so much for watching again, and see you guys next time.